And we're live. Hello. The microphone is this way because I put the camera on that way and I feel like it's wrong. Hi, Coffee. I've changed directions and I just feel weird. Hi, good morning. How are you doing? Yes, yippee. I'm here for now. Right now I am here. And that's a good thing, I think. Yeah. I think it's been 3 weeks since I've streamed, so it's been a while. And one note is that it's raining, so the chance of you hearing the rain is not 0. Just letting you know, I am aware that right now it's raining, and I'm really happy about it because I love it when it rains. Okay, I'll try not to max out the mic, but I don't really have a cough anymore. It's like it's remnants of a cough. I had a cough for a bit. And internet is good, so that's great. And yeah, I think I don't have anything besides saying hello, I'm back. And that I have no idea how my schedule is going to be in the future. I mean, I hope it's just going to be my Fridays and Saturdays. Yeah. I hope I could have a I don't know how, like, even from like 25th to 1st I was like, can I stream every day? I don't know. I really don't know. So let's not overpromise and underdeliver because I don't like that. Yeah, I lost my streak on Khan Academy because you have to like at least do one thing in like one thing a week, then you keep your streak, and I haven't touched it, so I lost my streak. But what I see is that there's a notification here. Is my voice too far? I feel like when I move that way my voice might be too far when I'm looking at the laptop, and then this way is where the mic is. But let me just have directionally be this way so that if anyone wants to adjust their volumes, this should be my normal voice. But I think it's lower than I want it to be. All right, I saw some notifications and it has to do watch 15 minutes of video on one topic. Oh, that's why it's calling me a listener, because we listen to the videos. Oh god, I don't remember anything. Where were we? What is with the star here? Recommended? Hey, rude. Recommended to retake? Is that really where we are? Did I fail the unit test? And am I supposed to redo it? It's 85. That's pretty good. Oh, but I haven't done. No. Who am I? Oh, hi. Hi, Momo. Good time of day. What's up? How are you doing? How's life going? My life? I mean, you didn't ask, but I'm like, how's my life going? The only thing that's on my mind is the fact that it's been raining the past, I wouldn't say week, but like, it's been raining and not raining the past week, and it just makes me so happy that we have rain. Algebra 1. Yeah, no, I don't, I think we already did this. I think I'm starting unit 4, right? Because it says 60%, which is not bad to me, right? And it says take again. You know what? If I feel like taking it again, I might, but I'm just not feeling like it right now. Okay, unit 4. Here we go. Do I hear weird sounds? If I hear weird sounds, I'm gonna mute, but for now we're good. Linear equations and graphs. Okay. I think it's going to be embarrassing if I fail this. So, I mean, fail or, but we have two variable linear equations intro. We have slopes. Okay. And then a quiz, and then horizontal and vertical lines, and then x and y intercepts. And then intercepts and slopes. This is the meat of it. Modeling with linear equations and inequalities. Quiz 3. Oh my god, that is a really long unit, but I am okay with it. Because even unit 5, 6, and 7 look like continuations of unit 4. So let's try to set a good foundation, right? Okay. I have muted you guys to you guys is hearing my computer. I just unmuted it. Now I can play the video and play the video.
What I'd like to introduce you to in this video is the idea of a linear equation.
Voice feels lower. I'm gonna have it go higher, but did you guys notice that YouTube didn't work and it switched to different server? That's what I noticed. Okay.
What I'd like to introduce you to in this video is the idea of a linear equation. And just to start ourselves out, let's look at some examples of linear equations. So for example, the equation y is equal to 2x minus 3. This is a linear equation. Now why do we call it a linear equation? Well, if you were to take the set of all of the xy pairs that satisfy this equation, and if you were to graph them on the coordinate plane, you would actually get a line. That's why it's called a linear equation. Let's actually feel good about that statement. Let's plot some of the xy pairs that satisfy this equation and then feel good that it does indeed generate a line. So I'm just going to pick some x values that make it easy to calculate the corresponding y values. So if x is equal to 0, y is going to be 2 times 0 minus 3, which is negative 3. And on our coordinate plane here, we're going to move 0 in the x direction, 0 in the horizontal direction, and we're going to go down 3 in the vertical direction, in the y direction. So that's that point there. If x is equal to 1, what is y equal to? Well, 2 times 1 is 2 minus 3 is negative 1. So we move positive 1 in the x direction and negative 1 or down 1 in the y direction. Now let's see, if x is equal to 2, what is y? 2 times 2 is 4, minus 3 is 1. When x is equal to 2, y is equal to 1. And hopefully you're seeing now that pattern. If I were to keep going, and I encourage you to, if you want, pause the video, try x equals 3 or x equals negative 1.
Yeah, but we're seeing a pattern of like the possibility of where the other data point might be.
And keep going, you will see that this is going to generate a line. And in fact, let me connect these dots and you will see the line that I'm talking about. So let me see if I can draw. I'm going to use the line tool here. Try to connect the dots as neatly as I can. There you go. This line that I have just drawn, this is the graph. This is the graph of y is equal to 2x minus 3. So if you were to graph all of the xy pairs that satisfy this equation, you are going to get this line. And you might be saying, hey, wait, hold on, Sal. You just tried some particular points. Why don't I just get a bunch of points? How do I actually get a line? Well, I just tried over here, I just tried integer values of x. But you could try any value in between here. All of these, it's actually a pretty neat concept. Any value of x that you input into this, you find the corresponding value for y, it will sit on this line. So for example, if we were to take x is equal to, actually let's say x is equal to negative 0.5. So if x is equal to negative 0.5, if we look at the line when x is equal to negative 0.5, it looks like y is equal to negative 4. That looks like that sits on the line. Well, let's verify that. If x is equal to negative, all right, that is negative 1/2, then what is y equal to? Let's see, 2 times negative 1/2. I'll try it out. 2 times negative 1/2 minus 3. Well, this is 2 times negative 1/2 is negative 1 minus 3 is indeed negative 4.
Is there anything else in this? Because if we're just talking about where the points might be, okay, different equation.
You could write a linear equation like this: 4x minus 3y is equal to 12. This also is a linear equation, and we can see that if we were to graph the xy pairs that satisfy this, we once again get a line, x and y. If x is equal to 0, then this goes away, and you have negative 3y is equal to 12. See, if negative 3y equals 12, then y would be equal to negative 4. 0, comma, negative 4. You can verify that. 4 times 0 minus 3 times negative 4, well, that's going to be equal to positive 12. And let's see, if y were to equal 0, then this is going to be 4 times x is equal to 12. Well, then x is equal to 3. And so you have the point 0, comma, negative 4, 0, comma, negative 4 on this line. And you have the point 3, comma, 0 on this line. 3, comma, 0. Did I do that right? Yep. So 0, comma, negative 4, and then 3, comma, 0. These are both going to be on this line.
And you can draw
3,
another line.
Comma, 0 is also on this line. So this line is going to look something like, I'll just try to hand draw it, something like that. So once again, all of the xy pairs that satisfy this, if you were to plot them out, it forms a line.
Indeed. Okay.
Now, what are some examples of, maybe you're saying, well, isn't any equation a linear equation?
No.
And the simple answer is no, not any equation is a linear equation. I'll give you some examples of nonlinear equations. So a nonlinear, whoops.
Don't we just need to raise the equation by...
Nonlinear equations. Well, those could include something like y is equal to x squared.
Ta-da.
If you graph this, you will see that this is going to be a curve. It could be something like x times y is equal to 12. This is also not going to be a line. Or it could be something like 5 over x.
I feel like I didn't know that x times y would not be a normal line. Huh. Okay.
Plus y is equal to 10. This also is not going to be a line. So now, and at some point, I encourage you to try to graph these things. These are actually quite interesting. But given that we've now seen examples of linear equations and nonlinear equations, let's see if we can come up with a definition for linear equations. One way to think about it is it's an equation that if you were to graph all the x and y pairs that satisfy this equation, you'll get a line. And that's actually literally where the word linear equation comes from. But another way to think about it is it's going to be an equation where every term is either going to be a constant. So for example, 12 is a constant. It's not going to change based on the value of some variable. 12 is 12. Or negative 3 is negative 3. So every term is either going to be a constant, or it's going to be a constant times a variable raised to the first power. So this is the constant 2 times x to the first power. This is the variable y raised
to me, nonlinear equations is variables raised to powers that are 2 and bigger. But apparently multiplication is also nonlinear, which, why do I feel like I didn't know that?
The first power, you could say this means this is just 1y. We're not dividing by x or y. We're not multiplying, or we don't have a term that has x to the second power, or x to the third power, or y to the fifth power. We just have y to the first power. We have x to the first power. We're not multiplying x and y together like we did over here. So if every term in your equation on either side of the equation is either a constant, or it's just some number times x, just x to the first power, or some number times y, and you're not multiplying your x's and y's together, you are dealing with a linear equation.
Okay, dealing with a linear equation. Yeah. Okay, I'm still in middle school right now. I mean, this intro video is very middle school, so take me to high school, please. What are we solving for? Just drawing stuff? Do I have the app open that helps me draw stuff? I have no idea. Oh, I do. Okay. Let's try to draw some stuff. Do I have it? Nope. Okay. Yes. Okay. I can do stuff. Cool.
Which of the ordered pairs is a solution of the following equation?
The volume is much lower than me, isn't it? I hope it's not annoying. But which are these solutions? Okay. I am a little sleepy. How much sleep did I get? 7 hours. I shouldn't be sleepy. Okay. Negative 3x minus y equals
Negative
oh wait, I'm trying to solve it with my eyes. If I put the 3's in there, we would get a positive 9 here minus 3. Yeah, that's correct. And if I get the 4's in there, we'd get a positive 12 minus 4 is not. So I would assume only the second one. Let's see.
3x minus y is equal to 6. What we have to remind ourselves is when we're given an ordered pair, the first number is the x coordinate and the second number is the y coordinate, or the y value. So when they tell us,
I know I have this thing on where if I'm not talking you cannot hear anything, but when I'm talking, can you hear the rain? Because I think you should hear the pitter patter. I'm talking so that I'm like, is it audible? I hope it is, because I like the sound of rain. The thing that's like on top of.
the ordered pair negative 4 comma 4, they're saying, hey, look, if x is equal to negative 4 and y is equal to positive 4, does that satisfy this equation? And what we can do is we can just try that out. So we have negative 3, and everywhere where we see an x, we can replace it with negative 4. So it's negative 3 times negative 4 minus, and everywhere we see a y, we can replace it with
The positive.
We replace it with positive 4. So negative 3 times x.
The answer is
y, which
12
is
minus 4 is 8, right?
It needs to be equal to 6. Now, is this indeed the case? Negative 3 times negative 4 is positive 12. Positive 12 minus 4. Positive 12 minus 4 is equal to 8. It's not equal to 6. Is not equal to 6. So this one does not work out. So let's see. Negative 3 comma 3.
Okay, I solved it. So let's just move on. Yay, that is correct. Okay, next video. Why am I looking forward to quizzes? What do I want to solve? Okay, next one is quiz. So let's finish this video. And
which of the ordered pairs is a solution of the following equation?
It was the same thing.
4x minus 1 is equal to 3y plus 5. Now, when we look at an ordered pair and we want to figure out whether...
Okay, I was yawning, so I just let the video play while I'm yawning. But I want to try and solve it with my eyes, but I feel like this is unsolvable with eyes. Let's try. So this is a 12, and then this is 6 and that's 11. Oh, first one is correct. Would it be the same for B? If x is 2, then we get an 8 on this side, minus 1, it's 7, and 3 times 3 is 9. Nope, so it's only the first one. Let's see if he solves it. And then the other one, the other side is much bigger than a 7, So it is only the first one. Good. My eye is working. Yes, practice time. Let's see if I... Okay. I feel like I want to solve it with my eyes. I need to visually monitor how the stream is doing, and it is very green. Woohoo. Okay, so why do we have two y's? That's just not nice. Alright, let's start with the first one. 2 times 4 is 8, plus I can at least write that part down so that I don't need to memorize it. So for A, we have 2 times 4, which is 8, plus 5 times 4 is 20, equals 6 times 4 is 24, right? Because 6 times 3 is 18. So, okay, 24 has to be. And then minus 5. So those two are not equal because that's 29 and that's 28. So A is not correct. Other way around. Also, this is not correct, but let's check B. 2 times 5 is 10. Let's write B. So we have 10 plus 4 times 4 is 16, equals 6 times 5. Is it 30? It is. Okay. My multiplication table is a bit weak. And then minus 4. This seems reasonable to me because this here is 26 and this here looks to be 26. So these two are. Yay! Answer is B. So yeah, nice. Awesome. And here is it trying to solve how the others don't match. Yes. Next question. Right, there we go. Same thing. So I think it's trying to get me to draw the X and Y axis and actually try to solve it, but I'm not doing that. Alright, let's try again with these examples. We have A, Y. For A, Y is 4, so we have a 4 equals negative 3 times negative 2, which is positive 6 minus 4. That is not correct, so we have both. I'm hoping the answer is neither or neither because if it's B again, it's just too convenient, like too coincidental. Yeah, that. And it's, I don't like it. 5 this time equals, it looks to be neither because negative 3 times negative 3 is 9. Wait, 9 minus 4 is 5. No. Well, the answer is B now. But is it? This is weird. I don't like the answer to be B twice. Oh well, let's do this one. X is a 10 for A. X is a 10 plus 7 times 1 is just 7, and that is indeed 17. So A is correct. Now I'm assuming it's both. Okay, let's see. B, like logically, it makes sense to be both. -4 for x, and then 7 times 3 is 21. Yeah, take 4 away from 21 is indeed 17. So the answer is both. Yay. Final question in this quiz. I'm enjoying this. I'm hoping the answer here is neither, because again, logically it makes sense to be that, but it could also be A. Let's see. So we have 8, well, y. We have 11 equals 8 plus 3. It does. Huh. So it is. I don't want it to be both. I want it to be just A. -5 equals -8 plus 3. That's correct. I don't like this. Because take away 3 from, or add to, -8. Same idea. Wait. 5 plus 3 is 8. Yeah, no. Correct. I don't like the fact we got two boths. That was really loud. And it's my fault. All right. Nice. Next video. 2 variable equations. We have been moving around with 2 variable equations, and if we're just solving for them, it's really like repetitive to me, but I will just be nice and continue because we have a quiz coming up. So let's listen in for a bit. Whoa, where, what? No audio? Oh no, it's loading. Why is it loading?
So this is an example from the Khan Academy exercise, graphing solutions to 2 variable linear equations. And they tell us to complete the table so each row represents a solution of the following equation. And they give us the equation, and then they want us to figure out what does y equal when x is equal to -5, and what does x equal when y is equal to 8. And to figure this out, I've actually copied and pasted this part of the problem onto my scratch pad. So let me get that out. And so this is the exact same problem. There's a couple of ways that we could try to tackle it. One way is you could try to simplify this more, get all your x's on one side and all your y's on the other side. Or we could just literally substitute when x equals -5, what must y equal? And actually, let me do it the second way first. So if we take this equation and we substitute x with -5, what do we get? We get -3 times, well, we're going to say x is -5 times -5.
So that's negative,
plus 7y
positive 15.
is equal to 5 times x is, once again, it's going to be -5. X is -5. 5 times -5
25.
plus 2y.
Negative.
-3 times -5 is positive 15 plus 7y is equal to -25 plus 2y. And now to solve for...
I'm just noting how cool his handwriting is. Like when I'm writing with my Wacom tablet, I'm writing with my dominant hand, which is my left hand, but I look like I'm writing with my right hand. Wait, did I just get a streak? Oh, I didn't notice that. I got a streak.
For y, let's see, I could subtract 2y from both sides so that I get rid of the 2y here on the right. So let me subtract 2y from both sides. And then if I want all my constants on the right-hand side, I can subtract 15 from both sides. So let me subtract 15 from both sides. And I am going to be left with 15 minus 15, that's 0. That's the whole point of subtracting 15 from both sides. So minus 15 here. 7y minus 2y. 7 of something minus 2 of that same something is going to be 5 of that something. It's going to be equal to 5y is equal to -25 minus 15. Well, that's going to be -40. And then 2y minus 2y, well, that's just going to be 0. That was the whole point of subtracting 2y from both sides. So you have 5 times y is equal to negative 40. Or if we divide both sides by 5, we would get y is equal to negative 8.
Nice.
So when x is equal to negative 5, y is equal to negative 8. Y.
Should I make an assumption even though it's not correct? So if x is negative 5, then y is negative 8. So if y is positive 8, would x be positive 5? Is that a wrong assumption to make? Probably.
Negative 8. And actually we can fill that in. So this y is going to be equal to negative 8. And now we got to figure this out. What does x equal when y is positive 8? Well, we can go back to our scratch pad here. And now let's take the same equation, but let's make y equal to positive 8. So you have negative 3x plus 7. Now y is going to be 8. Y is 8. 7 times 8 is equal to 5 times x plus 2 times, once again, y is 8. 2 times 8. So we get negative 3x plus 56, that's 56, is equal to 5x plus 16. Now, if we want to get all of our constants on one side and of all of our x terms on the other side, well, what could we do? Let's see, we could add 3x to both sides. That would get rid of all of the x's on this side and put them all on this side. So we're going to add 3x to both sides.
And the 16?
And let's see, if we want to get all the constants on the left-hand side, we'd want to get rid of the 16. So we could subtract 16 from the right-hand side. If we do it from the right, we're going to have to do it from the left as well. And we're going to be left with, these cancel out. 56 minus 16 is positive 40. And then, let's see, 16 minus 16 is 0. 5x plus 3x is equal to 8x. We get 8x is equal to 40. We could divide both sides by 8.
We get 5.
Get 5 is equal
oh my
to
God.
X. So this right over
My assumption was correct? Get out of here.
here is going to be equal to 5. So let's go back. Let's go back now. So when y is positive 8, x is positive 5. Now they ask us, use your two solutions to graph the equation. So let's see if we can do, oh, whoops, let me use my mouse now. So to graph the equation, so when x is negative 5, y is negative 8. So the point negative 5, comma, negative 8.
Ooh.
So that's right over there. Actually, let me move my browser up so you can see that. Negative 5, when x is negative 5, y is negative 8. And when x is positive 5, and we see that up here, when x is positive 5, y is positive 8. When x is positive 5, y is positive 8. And
I like this tool thingy.
we're done. We could check our answer if we like. We got it right. Now, I said there was two ways to tackle it. I kind of just did it, I guess you could say, the naive way. I just substituted negative 5 directly into this and solved for y. And then I substituted y equals
I mean, it would be easier to just drag this thing, right? It would work.
positive 8 directly into this and then solved for x. Another way that I could have done it, that actually probably would have been, or it for sure would have been the easier way to do it, is ahead of time to try to simplify this expression. So what I could have done right from the get-go is said, hey, let's put all my x's on one side and all my y's on the other side. So this is negative 3x plus 7y is equal to 5x plus 2.
I just said something silly. I said you could drag the x and y points on the graph, but the graph is not like limited by the equation. It's just a normal point thingy. Okay, I just realized that.
2y. And let's say I want to get all my y's on the left and all my x's on the right. So I don't want this negative 3x on the left, so I'd want to add 3x. Adding 3x would cancel this out, but I can't just do it on the left-hand side. I have to do it on the right-hand side as well. And then, if I want to get rid of this 2y on the right, I could subtract 2y from the right, but of course I'd also want to do it from the left. And then what am I left with? So negative 3x plus 3x is 0. 7y minus 2y is 5y. And then I have 5x plus 3x is 8x. 2y minus 2y is 0. And then if I wanted to, I could solve for y. I could divide both sides by 5, and I'd get y is equal to 8/5 x. So this right over here represents the same exact equation as this over here. It's just written in a different way. All of the x, y pairs that satisfy this would satisfy this, and vice versa. And this is much easier, because if x is now -5, if x is -5, y would be 8/5 times -5. Well, that's going to be -8. And when y is equal to 8, well, you actually could even do this up here. You could say 5 times 8 is equal to 8x. And then you could see, well, 5 times 8 is the same thing as 8 times 5. So x would be equal to 5. So I think this would actually have been a simpler way to do it. You see it all. I was able to do the entire problem in this little white space here, instead of having to do all of this slightly hairier algebra.
So I agree with him, but where's the but going? I would say if I had multiple things to test, then this would absolutely be better. Especially when it's like, all right, here we go. Especially when it's like you're trying to test multiple pointer thingies, x and y's. All right, what is the missing value in this solution? If y is -2, what would x be? Okay, I definitely need to simplify the equation. It's not really by choice. It's already like at least this side, -3x plus 12. And then we have this 2 here, so -2 would be 10. So -3x plus 10 equals y. So that's my simplified version. And then if y is -2, then why did I take everything to that side? I could have taken it to the other side. Well, at least I get a -10 here. If I move this there and have a -3x on this side, and here we get a -12 divided by -3 equals x. So the final answer is 4. Yes. Let's test that. Yay! I remember some math. That's so... 1! Oh, I love a good one. So 3 minus 7 is negative. What's with the 4? Why is every answer 4, even if it's negative? Yay! Next question is, we have y again, and should I solve it with my eyes or with my hands? We have 4x plus, well, -6, so -6 equals 10. So 4x equals 10 plus 6, right? Because it's negative. So we have a 16 on that side. Don't tell me the answer is 4 again. God. You know when answers are not logical? No, I swear to God, if the next answer is 4, I will do nothing because I don't feel like doing anything. Complete the missing value in the solution to the equation. We have x, and here I see a 12, and I see -9, and that's a 3, which is a good thing. Okay, just a 3. Thank God it was not a 4. It would have driven me crazy. I mean, I'm already half crazy, so that's fine. Okay, I got 4 out of 4 correct, and I got 400 energy points. By the way, I think 4 is my favorite number. I think. I don't have a favorite number, but if I did, it would have been 4. It would be 4. But it's just weird. Not logical. I need a break. We got one part finished. And I like slopes. I think I like slopes. I don't know what they were in the language that I...
Oh, go get a glass of water.
I do have...
C03CAF3 just redeemed.
I do have water with me. I was too lazy to make coffee. It was a mix of I don't want to make noise, and I was lazy. But I ate food before coming here. I think I was awake for like 40 something minutes before coming here. Sometimes, like most of the times, I'm like awake for like 20 minutes before coming here, because the whole prayer thing takes time. Yeah, like 15 to 20 minutes before. So here's me drinking some water. I'm going to mute the microphone. And YouTube recommended me a YouTube channel that is Monty Python live and like just skits. And I clicked it. I was like, "Oh, what is this?" It was skits. It was not the movies. But now hearing a Monty Python actor telling me to drink some water. Valid, fair. Okay, what do we do next? What do we do next? Yes. Yeah. I mean, this is me taking a break and talking, so I will continue talking. The most annoying thing, I mean, it was mostly a headache that I had last weekend. That was like too much. And I did take like pain relief. Right? Did I? I think I did. I did. But like the most annoying part was I call it my arm, but the actual pain itself is in the shoulder, but it makes the arm really heavy. So that was that. And yeah, I am very good because I forced my sibling to do yoga with me every evening the past week. And I know yoga makes me feel better. And then most days I don't do it. Which I'm like, I'm an adult. No, I shouldn't need candy to do things that is good for me. But I don't know. It's a mix of like being too lazy to do the thing, and like I need to create a routine so that it becomes mindless, and that friction of like, oh, I don't wanna part not be there. But honestly, I tracked my evenings mentally for like not the past week, but like the past few weeks, and the chance of me having a quiet evening where I can decide to do the things that I want to do is 50-50, because like surprisingly we get a lot of visitors, so just like when a visitor comes to your house, the chance of you doing the thing that you want to do lowers. And it's not like I feel obligated to sit with people, but I do feel obligated to sit with people. Like I could easily just go to the next room and do whatever I want to do, but yeah. Yes. Living in a bigger house is like that. And it's interesting because like I've never lived on my own, so I don't know what that sort of, I wouldn't even call it freedom. Like it's not really freedom. The freedom is for me. Freedom is coming home and having food without needing to prepare it, you know? That is my freedom, and I love that for me, for myself. Okay, I just talked too much. All right. So, we have been streaming for almost not really an hour. Let's call it 45 minutes exactly, because that 10 minutes doesn't count. And then do I have the energy to like finish this whole part and get to the quiz? Because wait, that was not even a quiz, it was just practice, huh? So the quiz would be both of them. It would almost be like me cutting this in half, right? Maybe not. Like it would be here. No, that's like 40%. I'm gonna just start, and then probably in the next 30 minutes I will see where my energy is. Yeah, like being away from streaming for 3 weeks and then coming back and doing a 2-hour stream might be too much, but let's see. What do we need slopes for, by the way? I mean, I know why we use slopes, but like, how do we work with them, with it? All right, let's check the audio level. I think it's low for it. I'm gonna try and I still don't know how volume affects OBS's like.
As we start to graph lines, we might notice
That scared me. I didn't press play. Rude. But I don't know when the volume goes up if it affects OBS's output. I haven't tested it. Let's try it just a bit. Like, okay, volume really low.
as we start to graph lines, we
Okay. And then volume really high. It shows the same.
might notice that there are differences between lines.
It is literally the same. I don't get it. Anyway, maybe I will do a playback later and see if it affects it. But yeah. All right, lines.
For example, this pink or this magenta line here, it looks steeper than this blue line. And what we'll see is this notion of steepness, how steep a line is, how quickly does it increase or how quickly does it decrease, is a really useful idea in mathematics. So ideally, we'd be able to assign a number to each of these lines or to any line that describes how steep it is, how quickly does it increase or decrease. So what's a reasonable way to do that? What's a reasonable way to assign a number to these lines that describe their steepness? Well, one way to think about it could say, well, how much does a line increase how much does a line increase in the vertical direction for a given increase in the horizontal direction? So let's write.
Okay, so slope is about the slope of the line. Okay, like what he said just now. Yes, so it's about the steepness. Okay, now I'm thinking about like mountains and hills. Yes. Okay.
Write this down. So let's say if we an increase in vertical for a given increase in horizontal, for a given increase in horizontal. So how could this give us a value? Well, let's look at that magenta line again. And let's just start at an arbitrary point of that magenta line, but I'll start at a point where it's going to be easy for me to figure out what point we're at. So if we were to start right here.
I have the thing on where it's like bass for your headphone, and I just turned it off. When he talks, I get like those surprise higher, like more bassy tones. Like I think it was, yeah, okay. Now it should be fixed. Let's try.
Here. And if I were to increase in the horizontal direction by 1, so I move 1 to the right, to get back on the line, how much do I have to increase in the vertical direction? Well, I have to increase in the vertical direction by 2. So at least for this magenta line, it looks like our increase in vertical is 2 whenever we have an increase in 1 in the horizontal direction. And we could, let's see, does that apply? Let's see, does that still work if I were to go if I were to start here, instead of increasing the horizontal direction by 1, if I were to increase in the horizontal direction, let's increase by 3. So now I've gone plus 3 in the horizontal direction. Then to get back on the line, how much do I have to increase in the vertical direction? I have to increase by 1, 2.
It goes up to 1. So we're counting this. 1, 2, 3, 4, 5, 6.
2, 3, 4, 5, 6. I have to increase by 6. So plus 6. So when I increase by 3 in the horizontal direction, I increase by 6 in the vertical. We're just saying, hey, let's just measure how much we increase in vertical for a given increase.
So each horizontal is half as much as the vertical. So it would be a 4/8 continuously, right?
Horizontal. Well, 2 over 1 is just 2, and that's the same thing as 6 over 3. So no matter where I start on this line, if I take and if I increase in the horizontal direction by a given amount, I'm going to increase twice as much in the vertical direction. So this notion of increase in vertical divided by increase in horizontal, this is what mathematicians use to describe the steepness of lines. And this is called the slope. So this is called the slope of a line.
Why don't I remember studying this? Like, it's very intuitive, but I don't remember studying this.
You're probably familiar with the notion of the word slope being used for, say, a ski slope, and that's because a ski slope has a certain inclination. It could have a steep slope
Incline, okay.
or a shallow slope. So slope is a measure for how steep something is. And the convention is we measure the increase in vertical for a given increase in horizontal. So 2 over 1 is equal to 6 over 3 is equal to 2. This is equal to the slope of this magenta line. So slope, so let me write this down.
The slope is 2.
Right over here, the slope of that line is going to be equal to 2. And one way to interpret that, if you, for whatever amount you increase in the horizontal direction, you're going to increase twice as much in the vertical direction. Now, what about this blue line here? What would be the slope of the blue line?
It looks like
Let me
1.
rewrite another way that you'll typically see the definition of slope. And this is just the convention that mathematicians have defined.
Like, yeah, but like this is obviously a 1 because if you put it on 0, you could just see it cutting through 1, 1, 2, 2, 3, 3.
For slope, but it's a valuable one. What is our change?
Slope is also the rate or derivative. Hello, hi. Am I losing my voice? No, right? I'm not. But yeah, never in the world. Hi. I don't know, like I do know, I have heard the word derivative, but I'm not sure what it refers to fully, but rate, yes. And like when we talk about something like gradient descent, hi, I'm good. I am very good. How are you doing? when we're talking about gradient descent, then the slope is like really important. And knowing, I mean, I'm guessing it's important because like knowing which direction to go and all of that is important. Don't you say?
In vertical for a given change in horizontal. And I'll introduce a new notation for you. So change in vertical, in this coordinate, it's going to be the vertical is our y coordinate, divided by our change in horizontal.
Cool.
And x is our horizontal coordinate in this coordinate.
Why is it y over x and not the other way around?
Plane right over here. And you might say, wait, you said
okay, derivative is like the change over something in calculus. Thank you. Okay, that cool. What do I remember about change? God, I all of the words that are in my head are in my language, so. But I do remember this change thingy, and having to do with calculating something for a motorcycle, like that's what I remember. What is acceleration? That's the thing, right? rise over run, derivative, and that would be, okay, which is the same as what's written here, right?
Change in, but then you drew this triangle. Well, this triangle, this is the Greek letter delta. This is the Greek letter delta. And it's a math symbol used to represent change in. So that's delta. Delta. And it literally means change in y. Change in y divided by.
I'm guessing that's why there's the, in your equation, there's the dy divided by dx because of delta, right? Calculus is used to find those in physics. Nice.
Change in x. Change in x. So if we want to find the slope of the blue line, we just have to say, well, how much does y change for given change in x? So the slope of the blue line
is 1.
So let's see. Actually, let me do this. Let me do it this way. Let me have a, let's just start at some point here.
Calculus is more fun than algebra. I don't yet have an opinion. Maybe someday I will. But as of this moment, I do not have an opinion about which part of math I like.
And let's say if my x changes by 2, so my delta x is equal to positive 2. What's my delta y going to be? What's going to be my change in y?
2.
Well, if I go to the right by 2 to get back on the line, I have to increase my y by 2. So my change in y is also going to be plus 2. So the slope of this blue line, which is change in y over change in x, we just saw that when our change in x is positive 2, our change in y is also positive 2. So our slope is 2 divided by 2, which is equal to 1, which tells us however much we increase in x, we're going to increase that same amount in y. And you see that. You increase 1 in x, you increase 1 in y. Increase 1 in x, increase 1 in y. From any point on the line, that's going to be true. You increase 3 in x, you're going to increase 3 in y.
Differential equations and then partial differential equations. I feel like I've heard of that. Again, I'm not sure exactly what it refers to. Differential equations. Yeah. Drawing a blank here.
Why? It's actually true the other way. If you decrease 1 in x, you're going to decrease 1 in y. If you decrease 2 in x, you're going to decrease 2 in y. And that makes sense from the math of it as well. Because if your change in x is negative 2, that's what we did right over here. Our change in x was negative 2. We went 2 back. Then your change in y is going to be negative 2 as well. Your change
which
in
is
y
positive.
Negative 2. And negative 2 divided by negative 2 is positive 1, which is your slope again.
So this reminds me of a normal stair. And next time I see a normal stair, I'm just going to call it what it is. The slope of 1. Most stairs have a slope of 1, but like some stairs have this part where after like crossing it halfway through, the x changes a bit by a factor of 2 most of the time. Yeah. That was just video 1. I need 2 more videos to get to the first thingy. What would the questions look like though? You can go from integral, death stairs, to derivative and then derivative to integral. Cool. I'm not sure what you're referring to. Because I mean now you already told me what derivative is. But yeah, can you hear the rain? The rain is nice. Yeah. More integral is the area under the curve. Area under the curve.
Defined as
Guy, sir, please. If I did not press play, do not play because it makes me feel weird. Yes. And about stairs? Yes. Why am I thinking of the stairs that lead upwards and there's nothing up there in the forest? It's a creepypasta, by the way. Yes. I think I have a hard time with concepts when it's not connected to an actual example. Then I can save that example in my head and refer back to it each time as a reference. When it comes to math. And can you hear the rain? Because it's really nice.
Slope is defined as your change in the vertical direction.
The audio is very low, and I really don't think there's much I can do about it. My audio is pretty loud. But at least there's the captions.
And I can use the Greek letter delta. This little triangle here is the Greek letter delta. It means change in the
Uh-oh, now you can actually hear the rain without... Uh-oh, the rain is too loud. I have to mute myself for you not to hear the rain. Interesting. It is raining, yes. And OBS is telling me you can hear the rain. If you want velocity from acceleration, you do the integral. Yes, very cool. I love rain. And if you want acceleration from velocity, okay, you take the derivative. Then that's what I have probably wanted. Cool. That is cool. Okay. Nice. And the rain is... Yes, it's chill now. If I'm quiet, then you won't hear it. It was just a moment of loudness.
vertical direction divided by change in the horizontal direction. That is the definition of slope, or the standard definition for slope, and it's a reasonable way for measuring how steep something is. So for example, if we're looking at the xy plane here, our change in the vertical direction is going to be a change in the y variable divided by a change in the horizontal direction is going to be a change in the x variable. And so let's see why that is a good definition for slope. Well, I could draw something with this.
Okay, the rain is picking up again. I really probably need to mute myself. Or maybe it's nice. Maybe it's nice background noise. I don't know how loud it is for you because I'm wearing headphones. It's pretty loud when I'm not wearing headphones. Of course it normally rains here, but like, thank you. Okay, I can keep it. But I hope it's not overriding the Khan Academy video. It's winter, so I mean, it didn't rain in November, which was sad. And like we have water insecurity issues. But yes, of course it rains. It rains even in... No, why would it be hot here all around? I was looking at the what is it called? Forecast, and it was like end of December we'll get negative. I mean -1 and 2, nothing serious, but like still we would get. No, we have 4 seasons. We have 4 normal seasons. I've actually had foreigner friends, like people who are not from here, have said, "What? You get 0 degrees?" It's like, yeah, we have seasons. So that's how it works. I mean, we are near the equator, so it makes sense for us to have all the seasons, right? Yeah, I like the rain. It's cool. It's alright. If you Google the country's name and write winter next to it, I don't get snow exactly where I live, but like half an hour drive, we get snow. So, yeah. Yeah. They make it out that Iraq is this very hot desert. I mean, parts could be. Oh, hi Gamma, Game the Gamma. Near the equator in the tropics it's more common to have 2 seasons. Okay then, we are a bit above the equator and we have 4 seasons. Hi Chad, hi. I mean, you said hi Chad and I'm reading it. Yeah, It's been a while because I was away for a while, but thank you for coming back, and I am also back. You can hear me, right? Because I can barely hear myself over the rain. Yeah, so rain is the thing that, I mean, thank God we don't get, what's my favorite season? Oh, that's a really difficult question to answer. I have a difficult time saying what's my favorite thing overall, but I love, like, you know, when you're a kid, you love summer because it's when you don't have school, and like I would be inside and watch stuff because the actual noon time where everybody's sleeping, it's too hot to go outside. So it used to be my favorite season, but I really, really, really love winter as well, because it's cozy, and now the rain is dying down. Okay. It's raining. Snow wouldn't be this loud. It is raining. And I like winter. I feel like I like winter as an adult because it gives me the promise of water. And like I said, the country will have water insecurity issues in the future. So I feel like it's more of a concern. But I really like winter as well. But my actual favorite seasons is a mix between autumn and spring. Because spring is the thing that's like really close to my heart, because we would like go on walks with my family or with my mom, and like I would pick flowers and I would take pictures. I dislike picking flowers because then I would kill the flowers, but that's what I would do as a kid. Now I don't do that. I just take pictures of the beautiful green landscape that we get. So if I had to choose between, even though I love autumn, like the vibes, and I feel like my favorite type of weather would probably be a cloudy, windy situation, which is what autumn is, fall, whatever. But this is really funny. I am breaking. This is breaking news that it rains in my country. Yeah. Oh, it's very hot in the summer. Yeah. Same with you, right? Like it reaches 45 and above, which is quite a lot. But yeah, I feel like I would choose spring, even though I love the vibe of autumn. But I have it like connected with school coming back, so that's the thing that would be like, and I'm like, I haven't been in school for so long, but you know, converting that to Fahrenheit. Oh, sorry, 100 degrees, and above. Yeah, I know 40 is 100. That I know of. Yeah. For Game the Gamma, I will tell you that it even snows here. What? But not exactly where I live. Yeah. And the only reason why I know 100 degrees Fahrenheit is 40 degrees Celsius is because I used to watch Ben 10. And there's an episode where Ben 10 is like, oh my god, it's too hot, it's 100 degrees. And I was like, oh, let me convert it. Oh, 40? That's not that hot. Yeah. And the rain is coming back, and it's going to be loud now. I actually don't think we have the humidity problem. I know people that even like, well, when it rains in the summer, it's humid and it's like sweaty. It never rains in the summer here, so actually it did rain once July this year for like 15 minutes, and it was just funny. You've never seen snow as a person in, like you have never seen snow? Not like you haven't seen snow in my country, because that would be like, why would you see snow in here? It snows. I think last time it snowed, it was like 2022 or 2021. something like that. Yeah. Oh, okay. So then you have actually never seen snow. That's wow. Huh. But like you could travel one way around and get snow, right? Go to see snow, because that's what we used to do when I was a kid. We would like drive to do what is it called? Snow fights? You know. Snowed here not too long ago. I'm not expecting snow this year, but I did see that it will snowball fights. That would make more sense, yes. Yeah. Even, oh, I remember, no, actually not me. Why did I steal this memory? But even when it snowed, in school, teachers would like let you have one lesson of like snowball fighting and then nothing else. Because it's a bit of a rare situation. But it does happen like every 5 or 10 years. Again, it snows in the mountain areas a lot. I think it snowed in February last year in one of the mountain areas. So it's not like we don't have it, but it's just not common to have it in the cities. And like even like in the some other, yeah. I will not name cities, but like I doubt it will ever snow in a place like Basra, you know? Because most of the time the hottest records are record in the country is recorded there. Oh, okay. Favorite time is winter. Snuggling under the covers and lazing around. That's the issue though. When you cannot do that, you know? Like, it's like something is being taken away from you when you have to go to work or you have to go to school. Like, if I had the freedom of staying in bed, then would I prefer summer over? You know what? I feel like I'm preferring spring over the other seasons, even though I love them equally, is because of the events we have. Right? Because then I have holidays and I'm at home and I'm enjoying the greenery. See? It's just association. There's a place to everything, I guess. Definitely. You can find that plus if you feel like it, yeah. Exactly. That's the downside. So yeah. But it's cool. I love, yeah. I don't know if it's a positive thing or a negative thing, but I don't think I could live anywhere else besides where I live. Whether it's related to the weather, that's funny, or if it's related to like, I don't know. Yeah, I am too connected and in love with my life. I like the trees being full of leaves in the summer. Uh-oh. The trees just die in the summer here. That would be spring though. For like a few yeah, exactly. Greenery, spring. I mean, depends on the tree, but like the orange tree doesn't die. But the hold up. How right now? Because I know the pomegranate trees have no leaves during the summer, but then when do they get it back? Because right now it's very yellow and really beautiful. Yeah. And why is it yellow? It's not autumn. It's winter. But yeah, no. Even winter, the trees should not have leaves, right? At least that's what I think. Which trees am I thinking of? Oh no, they all have leaves, but they're almost like dying. Because I took a picture of the leaves and I posted on Discord because there were dying leaves and they smell really nice. I think it has a name, right? The smell of earth. And yeah. Depending on the trees, yes. I don't know how to read that one, but yes. Evergreen versus that one. It looks like To me, it looks like it says decidus, like it's deciding to leave, to not have leaves. Yeah. I started reading this book from the author. No, deciduous, something like that. From the author of The Children of Time, and I'm gonna.
Deciduous.
Oh, okay, deciduous. I got it. Nice. Days are shorter, so they get less sunlight. It's amazing how precise things have to be to make life. Yes, that's what I'm trying to like comment about. I started this book called Shroud by the author of Children of Time, which is an amazing book, and it's a alien book, and the it's not a planet, it's a moon. It's always dark because it's tidally locked, and like just comparing it to like how used we are to our planet being the way it is, and how it like everything is just the configuration, you know, the way it is, of like having days, having seasons, having just, you know, the sun and everything, how precious all of that is. Why am I talking like I'm high? But yes, sometimes personally I just need to like be like, oh my god, I should be like just remembering to say alhamdulillah, which is just saying thank God, but like in Arabic. Is that more thankful? I have no idea. But you get my point, I hope. Oh god, it is indeed time. Yeah. And also just another note is that a friend who lives in a colder area was like, I love it when like flowers come out in May. And I was like, oh, flowers come out in April here. Huh. So like all of that association you have with like the seasons, our planet is very beautiful and we really should be grateful for it. So all of the associations of like, for me, rain is winter, but maybe for other people, rain is summer because you get those rainy seasons. So yeah, it's interesting, right? Like why I love a season is probably very different to why another person loves this season. And yes, it really does matter that it has holidays, and spring here has a bunch of holidays. Like the summer? Wait, hold up. No, what is it called? It's not the solstice. What is 21st of... first day of spring. There we go. That's what it is. We celebrate that, so... Yeah. Right, slopes. That's where I was. Huh. What is this button? Ooh. Huh. Hold up. I need to check because I remember it's on the 21st of month. Okay. Oh, okay. So it's just information. So it's again very country dependent, but for us, the first days of the seasons, March 21st is spring, and then December 21st is winter, and then going back September 21st is autumn, right? And then is it June 21st is... Do I have my 3 months correct? Because that's how it is. Each 3 month is the next season. Officially. We are simple people in Australia. We start our seasons on the... Oh. Huh. Or is it August 21st? August 21st has to be. No, that's not how it works. Then if I go back... Hold up. Okay, then it's June. Okay, September. I got it correct. Nice. I don't know why we start on the 21st. Ah. Really? What's with the 21st then? I think it has to do... I think Iranians celebrate as well. And I think it has to do with a different calendar. The 21st thingy. I don't know if it has to do with their calendar, but I feel like it has to do with their calendar. Now that I think about it. But why all of the seasons? Like, okay, I get it for spring because it's like the most important one. Because I'm very sure we say after the 21st of August is when the summer heat is gone. But it's still not the next season. You have to wait another month for the next season. Sometimes when you speak out loud, you're like, am I the only one who thinks that way? Or does everybody in my region think that way? Because for sure, spring is 21st of March. But what about the other stuff? You know? Like, am I the odd one? Am I the weird one? Or is everybody weird with me? But in a cute way, you know? I feel like I saw this be 10 and now it's 7 and I'm like, why? Or maybe, where did I see the 10? I'm very sure I saw a 10 here. Does it have to do with the skills? Like this is 13, 11? Often weather isn't... That's absolutely true, that weather is not about the seasons. Because if I compare right now to 20 years ago, very different. Like it'd be cold into spring, then suddenly 40 degrees. I feel like we had a short spring last year. Or this year, 2025. Because the more rain we get, the longer the spring will be. And technically spring is supposed to be 3 months, but it really isn't. So I agree with you. Yeah. But I'll pray for more rain. And hopefully safe rain. Because we had some issues. Inshallah it will be okay. I'm curious, and now I'm talking about the slopes. If we move X and Y around, what change would it make? Like if now it's Y divided by X, but if it's X divided by Y, what would that mean? What would we get? So this is slope.
Slope of 1. A slope of 1 might look something like, I could start it over here, and let me get my line tool out. So slope of 1, as X increases by 1, Y increases by 1. As X increases by 1, Y increases by 1. So slope of 1 is going to look like this. Is going to look like this. Notice, as I have a change in X, however much my change in X is, so for example here, my change in X is plus 2, is positive 2, I'm going to have the same change in Y.
Okay, we're talking about positive and negative slopes, and this is what a positive slope would look like. The negative slope would start from that side and end on this side. Correct?
A change in Y is going to be plus 2. So my change in Y divided by change in X is 2 divided by 2 is 1. So for this line, I have a slope. Slope is equal to 1. But what would a slope of 2 look like?
I mean,
Well,
we
slope
saw
of 2 should be steep
it a minute ago. Just show me the negative
y
slope.
direction. That.
Oh.
This line right over here, you see it. If my change in x is 1, change in x is equal to 1. My change in y is 2.
Yeah.
So change
Where?
in y over
Right.
change in x is going to be 2 over 1. The slope here is 2. And now hopefully you're
I feel like the other day at work, someone said something and I was like, nah. Oh, I caught myself. Why am I saying yes in Korean? I just caught myself again right now.
appreciating why this definition of slope is a good one. The higher the slope, the steeper it is. The faster it increases, the faster we increase in the vertical direction as we increase in the horizontal direction. Now, what would a negative slope be? So let's just think about what a line with a negative slope would mean.
It would start from here
Well,
and from
slope
there.
would mean that, well, we could take an example. If we have our change in y over change in x was, let's say it was equal to a negative 1. That means that if we have a change in x of 1, then in order to get negative 1 here, that means that our change in y would have to be equal to negative 1.
Right.
So a line with a negative slope, a negative 1
So
slope would look like.
One of them should be negative and the other one should be positive for us to get a negative answer.
Let me see if I can draw it.
It happens when learning another language, I suppose. I have those like moments where I'm in one language mode. Like right now, I feel like I should be in English mode. But when I watch series for like the next half an hour, I'm like in that mode because I watched it in that language. And I recently finished the series, and I really, really, really liked it. But I didn't want it to end that way. That's my like 10-second rant. It's a really good series. I loved the actors. I loved the shots and everything. And the story was pretty good. Like, especially the first few episodes, I feel like they were really strong. And the villain was really good. And the hero was really good. But then I just like the last episode, I was like, why did it end that way, you know? Are you setting up season 2? If so, tell me. or just end. Anyway. We're talking about slopes. Okay.
Would look like a negative 1 slope would look like this.
Nice.
Notice as x increases by a certain amount. So our delta x here is 1. Y decreases by that same amount instead of increasing. So now this is what we consider a downward sloping line.
And can't we have a negative x positive y as well?
So change in y is equal to negative 1. So our change in y over change in x over change in x is equal to negative 1 over 1, which is equal to negative 1. So the slope of this line is negative 1. Now, if you had a slope with negative 2, it would decrease even faster. So a line with a slope of negative 2, it could look something like this. Let me draw it.
I mean, technically, y itself is a line with, what would we call the slope? Something. Is it like, is x 0? Because then that would be infinity. Huh.
As x increases by 1, y would decrease by 2. As x increases by 1, y would decrease by 2. So it would look something like, let me see if I can, it would look like
This.
that. Notice, as our x increases by a certain amount, our y decreases by twice as much. So this right over here has a slope. This has a slope of negative 2. So hopefully this gives you a little bit more intuition for what slope represents and how the number that we use to represent slope, how you can use that to visualize how steep a line is. A very high positive slope, as x increases, y is going to increase fairly dramatically. If you have a negative slope, you're actually going to go, as x increases, your y is actually going to decrease. And then the higher the slope, the steeper in the more you increase as x increases, and the more negative the slope, the more you decrease as x increases.
Now my question is, how do we get questions? Oh really, it's still a video. We get an example and then we get a question. Because I thought it would be the practice thingy. Example first, then practice thingy.
Find the slope of the line.
Is this recorded on a Nokia phone? I mean, I'm not gonna blame it because it's from like probably 15 years ago. And I'm thankful for its existence. Is that full screen? I don't want it full screen. I want it like this much.
In the graph. And just as a bit of a review, slope is just telling us how steep a line is. And the best way to view it, slope is equal to change in y over change in x over change in x. And for a constant, this will for a line, this will always be constant. And sometimes you might see it written like this. You might see this triangle. That's a capital delta. That means change in y over change in x. That's just a fancy way of saying change in y over change in x. So let's see what this change in y is for any change in x. So let's start at some point that seems pretty reasonable to read from this table right here, from this graph. So let's see, we're starting here. Let me do it in a more vibrant color. So let's say we start at that point right there. And we want to go to another point that's pretty straightforward to read. So we can move to that point right there. We can literally pick any 2 points on this line. I'm just picking ones that are at nice integer coordinates, so it's easy.
Oh, so now I see a positive change in x from -3 to 0, and then a positive change in y from -3 to 1. So it's 3. 1, 2, 3 to 2. 2 divided by 3? Hello? Whoa, how can I read that name? Can you help me with a name? Thank you. I appreciate that. Give me a name so that I can call you something. I see Avon at the end. And that's me being lazy. Yeah, the model is I'm using an application that I put in the description if you're curious about what the application's name is, because I didn't create it myself. Anyone can create a model.
Easy to read. So what is the change in y and what is the change in x? So first let's look at the change in x. So if we go from there to there, what is the change in x?
3.
My change in x is equal to what? Well, I could just count it out. I would go, I went 1 step, 2 steps, 3
Tony!
steps. My change in x.
Wow. Hi, Tony. I'm CL.
X is 3. And you can even see it from the x values. If I go from -3 to 0, I went up by 3. So my change in x is 3. So let me write this. Change in x, delta x is equal to 3. And what's my change in y? Well, my change in y, I'm going from -3 up to -1. Or you could just say, 1, 2. So my change in y is equal to +2. So let me write that down. Change
And we just make the slope. The slope is 2 divided by 3. That's it.
in y is equal to 2. So what is my change in y for a change in x? Well, when my change in x was 3, my change in y is 2. So this is my slope. And one thing I want to do, I want to show you that I could have really picked any 2 points here. Let's say I didn't pick. Let me clear this out.
But I trust you.
Let's say I didn't pick those 2 points. Let me pick some other points. And I'll even go in a different direction. And I want to show you that you're going to get the same answer. Let's say I view this as my starting point. And I want to go all the way over there. So what is my. Well, think about the change in y first. So the change in y.
I mean, I would want to start at 0 because I don't want negative numbers, but fine. Change in y. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Exactly the same.
I am going down. I am going down by how many? How many units? 1, 2, 3, 4 units. So my change in y in this example is -4. I went from 1 to -3.
Ah, wait, so we're going from here to here and we're moving in a negative direction, but if we went from here to there, we'd move in a positive direction?
That's -4. That's my change in y. Change in y is equal to -4. Now what is my change in x? Well, I'm going from this point, or from this x value, all the way, let me do that in a different color, all the way back like this. So I'm going to the left, so it's going to be a negative change in x. And I went 1, 2, 3, 4, 5, 6 units back. So my change in x is
And the answer is like
equal
going to be
-6.
2, 4, and 6, both negative, so we get a positive 2 divided by 3.
Change in x is equal to -6. And you could even see I started at an x is equal to 3, and I went all the way to x is equal to a -3. That's a change of -6. I went 6 to the left, or a change of -6. So what is my change in y over change in x? My change in y over change in x is equal to -4 over -6. The negatives cancel out, and what's 4 over 6? Well, that's just 2 over 3.
Ta-da!
So it's the same value, you just have to be consistent. If this is my start point, I went down 4, and then I went back 6. -4 over -6. If I viewed this as my starting point, I could say that I went up 4. So it'd be a change in y would be 4. And then my change in x would be 6. And either way, once again, change in y over change in x is going to be 4 over 6. 2/3. So no matter which point you choose, as long as you kind of think about it in a consistent way, you're going to get the same value for slope.
Cool. And now we get an exercise of 4 questions. And that is where I'm going to do the exercise and then pause the stream. If slope is delta x divided by delta y, then it is correct to say that k delta y divided by it's a slippery slope. That's a funny one. Given k is more than x. Oh, if we increase the y, then the more we increase it, the more slippery it gets. Indeed. You have written the word slippery slope in math. That's funny. Okay. What is the slope of this line? Okay, so we're just going to do the thing that he did. We're going to pick 2 lines. I'm going to pick an easy one. I don't like this. Well, I'm just going to, let's pick this line versus that line. That's easy. Both of them are positive. Even though x is now -1 this way. So we have change in x is negative. This is an equal sign. 1. And then change in y is 1, 2, 3. So we have 3, -1. So final answer is -3. Right? Because that was positive, but this was negative. -3. Let's check. Correct. Woohoo. Okay, I like this. This is not difficult because I get to choose the things that I want to choose. And again, I'm choosing 1 here, and I'm choosing. Should we just choose 2? Let's choose something more so that it's more fancy. I'm going to go from here to here, even though I could go from here to here. Should we do y first, then x? Because now y is coming down 1, 2, 3. So now we have a -3 on the y side, y. And then on the x side, we have a 1 and a 2 and a 3. And I saw the 1, 1 coming a mile away, but I was like, you know what? I'm going to be, game the delta. That's funny. Because I was like, wait, the difference between 2 and 1 is just a 1. But then I was like, no. So yeah, both this slope is a 1. Yay! 2 more questions. This slope is negative. And if I choose this 3 over here, and then let's choose this here, and go, I see 1 and 2 on the x side negatively, and I see 1 on the y side positively. So it's 1 divided by 2, but negative. So it's a half. It's a negative half. This slope is a negative half. How would I write it? Can I just write it negative 1 divided by 2? Oh, I could. Huh. And then that one looks... Is that a 1, 1? No. Can you see? Like here, it's not exactly on the dot. Noise. Like not everything is on the dot, and it is making me feel weird. I don't like it. Making me feel icky. Like this is the only one that's exactly on the dot, and then nothing else is except for that one. So that's what I'm going to choose. The ones that are exactly on the dot. Okay. You, and then you. Because I don't have the energy to calculate stuff that is incalculable. This is our meeting point. So we have a 1, a 2, a 3, a 4. So our x is negative 4. And for y, we have a 1, a 2, a 3, a 4, 5, 6, 7. Oh god, that took too long. 7. I was about to say 3. Huh? What? Why? But there's an extra one over here. Okay. 7 divided by negative 4. I am not gonna simplify this at all. And I hope it accepts it. Negative 7 divided by 4. I won't even read it, what Coffee has written. I'm too old for this. Uh-oh. We made a mistake. I made a mistake. Why should I put you? Alright. I'll accept that. It looks difficult. But it's annoying. Like nothing is on the line. Like if I do this here and this here. What is this? What is this? And if I do here with... Does it want me to simplify it? Like these are the only things that I feel comfortable with trying. And 1, 2, 3, 4, 5, 6, 7. Oh, because I'm counting. I forgot I'm counting, and it includes the numbers 7 and 6, but the other way around. Huh. I didn't realize it. Uh-oh. No! Okay, I can say 7, 6. I could do that. I can do that. What? And then here's a 1, and a 2, and a 3, and a 4. Do I need to... Are they both... No. This part is correct. But if it needs me to simplify it, I could do that. 7 divided by 4 is 1.75. Negative 1.75. Is that what you expect of me? No. So when y is negative 3, I actually don't understand what you're saying, because the one side is 3, your x is 3, and your y is 12? Where did you get that? I'm going to ask it to show me the steps because... Oh my god, they're both positive. Darn it. It's positive? But I was going that way. And that way is negative. Well, I'll get the bonus question. It's fine. Oh, it was a positive slope. I should have noticed. This is a negative slope, so that's fine. Here's one on the dot. And then there's another one all the way over here on the dot. And you can see me moving negatively. 1, 2, 3. And then here, 1, 2, 3, 4, 5. And then the other number, and then 8. Because it's from 4 to 4. Yay. But if I am going up technically, so that is the positive side, and then the negative side is 1, 2, 3, 8 divided by 3, right? Negatively. 8 divided by 3 is not divisible, so I mean, I know I could write. Thank God we did it. Yay! Good job. And if I go back to the main thingy, this is where we are. It's a pretty long one, but it's okay. And we are half-ish way through the slopes. It's a slippery slope. You did it with me. We did it together. Yeah. This is, it's not a sprint, it's a marathon. So it's taking its time because both I'm human and I skip sometimes. And then because I don't feel like studying, like I feel like today in my 1 hour and 57 minutes, I feel like I studied for 1 hour, which is pretty good, right? Yeah. Pat on the back. Good job, me. I am actively working on a video that I haven't even recorded, but I would love to get it get it out before the end of the year. That is my goal. So please keep me accountable on that. And right now, my plan is just to continue the way we are. I will say I really have a hard time. If anyone noticed, I started the stream half an hour later than I normally would. That's because the sun is rising very late, and when I need to wake up for prayer, thank you. Thank you, I appreciate that. But when I wake up for prayer, it's later than usual, and like normally I would wake up, pray, and then come and do my stream. But if I try to do that with my normal time, then prayer hasn't even happened. Adhan hasn't even happened. Has it? Sort of. 10 minutes. It's happened. And I was like, I could prepare for prayer, wait for Adhan, start the stream, do the prayer. I could do that. I don't know if I want to, you know? Because then I wouldn't get the chance to do the other lazying around stuff that I normally do. So that's why I started half an hour late. And I feel like I might in the foreseeable short days of winter future. Yeah. Because like 6:30 is my winter schedule. 6 is my summer schedule. I think. Well, not summer, but like longer days. It really depends on the prayer. Like it is 100% connected to the prayer time. And I think today's prayer time was like 10 minutes before 6. Something like that. Yeah. So that is how I schedule. You know, they say stack your things. And that's how I do my task stacking. Prayer and then streaming. It's really actually, it feels right when you stack tasks with your prayers. That's what I do. Like, I sometimes take a walk after afternoon prayer and all of that. Pretty fun. Does it look like I'm trying to convert you guys? I'm sorry if it does. Sometimes I'm like, I swear I'm not trying to convert you. I'm just saying how convenient it is. And I'm sure you guys are also very, like, you do similar stuff, habit stacking and all of that. Okay. Maybe next time I'll try to convert everybody, but not today. You won't make us morning people. As a certified night owl, I could try to convince you to become a morning person, but even I'm not fully convinced. So, that's the conversion you mean? Of course, that's the conversion I meant. There are so many conversions I could try. You're giving me ideas. But yeah. I don't think I will go back to being like the night owl of like 2 a.m., 3 a.m., but I don't mind staying up until 12, a few days a night. And then ruining my schedule and then trying to fix my sleeping schedule. Did it happen to me when I was sick? I think it did happen to me, and now I'm trying to fix it. No, it's fun. No, it's absolutely just fun. Funsies. Okay. I am going to try and end this lovely stream. Thank you, honestly, for being so welcoming and understanding. Because I really note that as a person who streams, I don't feel like I should even call myself a streamer, even though I've been streaming for way too long. I'm not as communicative as I see people on Twitter being, like about their schedules, about their plans. I don't think I have an actual plan. I mean, my plan is studying, but there are people who are really good at what they do, and they're putting their efforts into streaming, and I'm like, wow, good for you. I just don't have the same energy. I'm just like chill. I appreciate that. Thank you. I really, really do. Like, right now you are giving your time to me, and I hope I can give back whatever I can. Oh, hi! Yeah, it's been a while. You're Aaron, right? Thank you. So, inshallah, see you next time, which is Friday on my time, and who knows what time it is on your time. Yeah, so I appreciate you for being here. Yeah, see, I got you right. And yeah, catch you next time, whether it's on any platform. You don't have to be here, but if you are, I appreciate that. So I'm going to go to the end screen, and I wish you a lovely rest of your day or night. Thank you. Bye-bye. Yep, bye. I'm waving my hand actually in real life. Okay, bye-bye.